So for the mist, we're going to split this into two parts. First part is going to be a smoke, and the second part is going to be some small particles ejected through that smoke just to give it a bit more reflective appearance and more sprayish, misty kind of look, just to break up that uniform soft volume feel that we get if we just do a normal smoke simulation. And so first off, we're going to start with the smoke source. Let's head over to our scene where we left off last time, where we just created the post process for the whitewater. And now let's start creating our source for our smoke sim. The best thing to start off, I think, would be just to grab our emission here that we have from our whitewater source. So if we go in a couple of frames, so just use this as a base emission. So let's just drop down a object merge, quickly drag this here into that top field, and then just cut that and put it down here. So this is going to be our get emission whitewater. And then we want the same for our volumes. So whitewater volumes. In this case, we want the velocity. And based on the velocity, we want to start to modify this density field. So if we do have like something that moves slower, we want to cut it off. And first, what we're going to do here is, if we see this, the field is basically called emit. What we want is this field to be called density. The easiest way is just drop down a name and then call this density. This just renames basically the name field, and then we call our volume field density. Let's drop down a volume VOP, just so we also do VOPs instead of wrangles. We could also do this in a volume wrangle, but yeah, I'm trying to force myself to do more of this just to please those of you that do a lot in VOPs. But maybe it's also interesting to see how you can really speed up your workflow. Or I mean, I guess it depends on your habit, but for me, using wrangles is really a speed up because you can really quickly just start typing, and then you really quickly see what you're actually doing. So let's drop down a volume sample and sample that velocity field. The sample position is going to be our current point position, or our current voxel position, and the input is going to be the second input. And the volume that we want to sample is going to be, say, primitive name, and then we can say we want to sample our velocity field. One thing that I just noticed is we can't use the volume sample. We have to use a volume sample V, because we want to actually sample a vector field. So let's just quickly change that. Volume sample vector. Again, hook up the position, change this to the second input, and the primitive name is going to be our velocity. So let's get rid of this one here. Now let's take the length of our velocity, and then base of that, this is our speed, and then base of this, we're going to start to multiply down our density. So let's fit our incoming speed and just promote these two parameters. So promote the source min and max, and then we'll take that result and multiply down our density field. So already we can see it already checked away some of the parts. We just want to go ahead and change these values. So minimum value 2, maximum value 3, and so we just have higher velocity densities that are actually contributing. So if we disable this, we see there's like some slow moving stuff, and now we just have things that move really fast are also are just contributing to the density field that we're later going to be using for our whitewater smoke source. So let's just call this clamp, or not clamp, density mod vel based. And in addition to this, we also want to basically replicate what our whitewater solver is doing. So let's again grab our whitewater emit, drop down a scatter, and then we're going to be scattering inside of the volume. The rule that we want to be using here is the same that is getting used if we look up in, where is it, our whitewater source. So if we just switch quickly to manual mode, jump inside here, and then, because if you remember here on the whitewater source, we can actually visualize our points by setting a whitewater scale and the emission amount, the same as we do it inside our whitewater sim. So let's just jump inside here, and then if we look for here, create emitters. And so what we want to use is the same expression that they have here. So let's just allow editing of contents. And it's grabbing the emission amount divided by the power of the whitewater scale. So the power to 3. And so let's just grab this expression here and switch it for the actual settings. So it's force total count, density scale, and then right now it's 0 because it can't find these attributes. So we want to actually point them to our whitewater sim. So if we go inside here, whitewater solver, first copy our scale, and let's go to our scale. So this is our scale here. Just select this, paste relative reference, and then also grab our emission amount, which we find under the emission tab, and emission amount. And let's add this here. Paste relative reference, and now this should evaluate correctly. Very nice. And then I think the max points, we can probably add another 0 there just in case. And we do not want any relaxation of the points, since this is just going to slow down everything and also give a unnatural look and feel. So jump back to auto update, and right off we already see some really nice emission here from our density field. And what we will do now is, since we don't have any velocity here, we're going to sample our velocity. There's also a couple of different ways you can do this. For us, our good old friend, the wrangle, really easy and fast. Drop down a wrangle, and then we're going to do so vector at velocity is equals to our volume sample v. So this one here. And then second input, we want to sample our velocity field at the current position. And now if we go ahead one frame just to refresh this, we should actually be getting maybe, yeah, because we have to connect this to our, there we go, to our volumes coming in here. And now we have our velocity on our points, which we will need later. So first, before we start continuing here, we want to get rid of all this stuff down here. So let's drop down a wrangle, hook this up here, and then if our position, so vector at position.y is smaller than 0.1, then remove the point. Remove 0.0 and the current point number. There we go. Now we just have the top part. So clamp y. This is our sample velocity. And now we want to delete based off of speed. So let's grab our speed, which will be our velocity length, and that is equals to the length of our velocity fitted between 0 and the max velocity here, and fit this to 0 and 1. And now if let's just quickly create some random at point number plus a seed. I mean, we've done this a couple of times now, so you should be familiar. And if this is greater than the ramp of our remap, delete. And this is based off of our velocity length. We will remove the point. Remove point, input 0, and the current point number. All right. So max velocity, just set this to 1. And our seed, I don't know, something random. Let's remap this here to be a spline and then have this basically cut off somewhere here. And so now we can see that our really slow moving points, like these ones here, that don't have any velocity, get removed. And since also when this starts to settle, everything that is below this max velocity we don't want to keep. So delete, speed based. Also save this as a preset, since this is something that is really handy when working with particles and sources and creating sources for smokes, and something very standard. The reason why we just didn't cut everything that is below 1, so this is like a ramp. We're just generating like a random for each point, and then using that or using our velocity length that we refitted as a threshold delete. So if you remember from our random delete, it's basically the same. So delete random, this threshold is now our velocity length. So the higher this is, so for example at 1, we definitely want to keep it. So it's the other way around than here. But so with 1, we want to keep it. And then everything that goes below this velocity of 1 definitely has a higher chance of getting deleted until we reach 0. And that's why I also created this really soft or this really steep going in, so we could also higher this. So definitely the particles that are at 0 will get deleted, and it just value 0. So perfect. So from here on up until there, it's going to start to ramp up. We could also here specify a minimum velocity where we say we want to have everything that is definitely below this get deleted, but I'll leave that up to you to change that if you want. And now we want to take these points here and just stretch them along their velocity. So let's drop down another angle here. Same kind of thing. Create a random value, float, and this is going to be a random multiplier, which is equals to random based off the point number plus a seed. Not sure how many times we have already created this expression, but yeah. So, and then what we will do is our position plus our velocity, and then we're going to multiply this by our fitted random multiplier. So grab our random multiplier here, and then we're going to say input is 0, maximum is 1, and then we want to refit this CHF min, and then CHF max. And this is basically the stretch, as you'll see in a moment. Right now, there's nothing happening because we're not doing anything. Let's just add a random seed here. And then, so basically what we can do now, as soon as we start to move this, we're stretching the points randomly along their velocity, and therefore getting like this kind of streak. And this really, really helps avoiding like these stepping behaviors that you have when you start to sources, because some of this stuff is moving quite fast. And so what we want to move it is in the negative direction, so going backwards where it came from. So we don't have anything leading ahead, but we want to have it trail. And the amount of the trail is basically the amount that it would move in one time step. So it just fills up the gap from one frame to another. And the velocity is in seconds. So basically, if we measure the speed, that would be how far or how fast it would move within 1 second. And so what we want to do is take that and move it one value or by divided by the frames per second. So then we get basically the amount that it would have to move for each frame and not per second. Since this is happening on each frame, we want to have this stretch happening. So it's going to be -1 divided by our frames per second. And I think we already had this inside our whitewater simulation. And now, so I can quickly show you if you just drop down a trail. And let's just trail this. And now we have 2 or 4. Let's go for 4. Trail length of 4. Now we can see this is continuous and not leaving any gaps. And if we would disable this, you can then see the substepping that would appear if we go across multiple frames. So now you can see here we get, this is where how our emission would happen. So here, 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 and through this, we're just stretching it. And then therefore removing gaps. And this is like one of my favorite techniques to get rid of substepping, especially when dealing with particle emission, stuff like that. So stretch along velocity. Remember to save this as well, so you can reuse that later, because you will be doing this quite a lot. So stretch along velocity. And now we want to rasterize this. And so let's just drop down another wrangle here. Wow, I think this is the longest wrangle tree I created here in this tutorial. I'm sorry for that, but it's super handy and just some simple stuff here going on. So just Y clamp, sample velocity, and then these are a bit more complicated, but also very straightforward. And the last part we want to do, we just want to initialize our attributes here for the rasterization. So we're going to set our density equals to 1. And then our p-scale equals to our p-scale. Oops, p-scale, which we're later then going to hook up to our rasterize, and then set our velocity field to our vector field. So let's just say init rasterize attributes, and then let's drop down a volume rasterize attributes. Hook this up. I'm not going too in depth about these nodes here or like the volume simulation part, because this would be its own class for Pyro. I mean, I'm going to go through the settings that we use, but not going to go too in depth. So here the attributes that we want to rasterize is density and our velocity field. The coverage attribute is going to be the density attribute. So these are the areas that we're going to be sampling in. And our voxel size is going to be 0.04. And we're going to take this here, copy parameter, and here, let's first create our parameters and then paste relative reference and multiply this times 1.25, just so we get a bigger p-scale than the voxel size, so we actually fill in the areas and have a bit of overlap. Now, just to smooth out this a bit, we're going to also do a velocity blur. As you can see here, we're already getting a bit nicer result. One thing that we can do is let's just drop down a blast and hook up our density field, delete and non-selected, just so we can only see the density field here. And now we can really see this velocity blur kicking in here. It smooths out and gets rid of this pointy behavior. And we just want to have a shutter offset of -1, just so we trail backwards. So it just goes backwards and nothing is going to shoot out ahead. And maybe let's just blur it a bit more. So shutter of 1, so run from one frame to the next. If you really have like really fast moving particles, you can also up the blur samples. It doesn't cost too much, but it helps smooth out like if you have bigger gaps and then start to get stepping due to the samples here, because this specifies how many times it's gonna basically streak backwards. And so now we just want to add another rule for our density field, and we want to just accumulate it. Now as the last part, let's just get rid of this here. We want to drop down a volume velocity just to disturb our velocity field a bit. So drop down volume velocity, and this is just super basic disturbing. And so here, let's say velocity field, and come to our, where is it? Curl noise field, add curl noise. Go down the scale, 0.5 or something. Also, let's just quickly create a volume slice to visualize our velocity field here, and then a volume trail. Hook this up for the points, and then this here. And now let's specify our velocity field. And now we can see our velocity field, how this behaves. And once we start adding here our curl noise, you can see the strength really disturbing it here. We just want to go for something really subtle. Swirl size, let's go for 0.1, just to have a smaller behavior here. Up the grain a bit to get a bit more chaotic feel. And for the turbulence, let's go for 4, just to add a bit more detail in the smaller areas. And as you can see here, for example, we were at 3 and 4. Just adds a bit more detail. I think that's it for this part here. Now let's just combine these fields here. So let's do a VDB combine. Take this one here and combine this one here and just add them together. And just say we want to add the density field and the density field. And now if we have a look here, this is our emission for our smoke. And the reason why I added this second part here is just to have a bit more control over the sourcing. This is just like some additional stuff that we're getting from the whitewater emission. And then here we're creating basically our own, where we're also streaking along the velocity and to fill the gaps so we don't have to go crazy in the substeps, since the smoke sim that we're doing here is super basic. One thing that we do want to do is drop down a VDB activate to deactivate regions that we don't need anymore, just in case. So if you have a look here, this is the size of all the fields, and if we create this deactivate, we reduce it down to this area here. So it doesn't really change anything of the overall look, it just makes it more efficient. And now we should have our velocity field and our density field. The velocity field coming in from this stream. We're not using the one here provided because we do want to have the one that were sampled from the points, and also the one that we disturbed here. So let's drop down a cache node here. So ROP cacher, call this our cache whitewater smoke, and then source. And then here, let's just drop down a null so we can later reference this in our sim, and we'll call this our out whitewater mist smoke. And let's color this. And now we should be good to go there.